Okay, so let's cover section 1.5, proofs that are not valid. So some things to keep in mind before we do a couple of examples here. It says a single error in reasoning can destroy a deductive proof, and this will result in an invalid or unsupported conclusion. So there's a few tricks that you can look for that are errors, and hopefully they can help you to determine if a proof can be valid or not. Common errors to look for in proofs. Okay, so it's sort of the common errors that you can look for. Number one, a false assumption or generalization. Okay, look for if they say only or all. Okay, all things have to be this way because you can probably find a counterexample that isn't. If they use stereotypes, like all women like to cook, for example, or all men like to build things. So those are the kind of things that you're looking for in a false assumption or generalization. That's the first kind of error. Second error is an error in reasoning like division by zero. So an error in reasoning means using math processes that you know don't work, like dividing by zero isn't allowed. Number three, an error in calculation. This is flat out if you just add 2 and 2 and get 5 for whatever reason. Of course, that's going to make your proof invalid. And number four, faulty logic. So if you are using some type of reasoning that someone could easily disprove, then of course that would make your proof invalid. Okay. So it says here, be careful to avoid circular reasoning. That is assuming a result that follows from what you're trying to prove. And it says when you write a proof, be sure that it is clear and correct. Ask someone else to read your proof to see how it can be improved. See if they can punch holes in it and figure out a reason why it couldn't be true. Okay, so there's two types of examples that we're going to go over here. And I'm going to ask you what type of error, okay? And that's what your quiz is going to be about. What type of error occurs in this deduction? So in example number one, it says all people over 65 are retired, and Corbin's over 65, so he's retired. So there is an error in this deduction. Do you think that it is a false assumption or generalization? Is it an error in reasoning like division by zero? Is it an error in calculation, or is it faulty logic? All right, well, it's certainly not an error in reasoning like division by zero. There's no math in this question. So it's certainly not number two. And number three, it's not an error in calculation either, and we're not calculating anything. All right, so it's either going to be a false assumption and generalization or a faulty logic. Now, remember what I said, careful about generalizations or stereotypes. So this first sentence says all people over 65 are retired. Can you think of anybody over 65 that isn't retired? Because if you can, then you're making a false assumption or you're making a generalization, because not all people over 65 are retired, okay? So that would be the type of error in this deduction. You're assuming falsely that all 60 people over 65 are retired, okay? So that's all you'd have to say. This type of error would be a false assumption or generalization. All right, example number two says what type of error occurs in this deduction? So they start off here by saying 6 equals 6. And if you want to think of left side, right side, because it's an equation, that's fine. So on the left side I have 6, on the right side I have 6. That's fine. All right, second line, they are taking each of these 6's and multiplying it by 2.5. So the second line I have the 6 times 2.5. And on the right side, I have the 6, which they've split into 3 plus 3, because 3 plus 3 is 6, and they're multiplying by 2.5. On the third line, notice that they have added a 1 on each side. So line 3 is exactly like line 2, but they're adding plus 1. Line 4, it looks like they've converted 2.5 times 6 into 15 plus 1. And over here, they have 7.5 plus 4. So they've taken 2.5 times 3 to be 7.5, and they've done 3 plus 1 is 4. And then they're coming up with a statement that they're saying, well, 16 is the same as 11.5, which we know isn't true. So there is an error, absolutely, because there's no way that 16 equals 11.5. All right, so let's start with number one. Did they make a false assumption? Well, there's no assuming here, so it's not number one. All right. Number 2, an error in reasoning like division by 0. So that means using math concepts that aren't true. So they're certainly not dividing here. Number 3 says an error in calculation. Do you think that they've made an error anywhere and they've calculated? For faulty logic, that's not it either, okay? This is just a straight calculation question. So it's either an error in reasoning or it's an error in calculation. Well, have you spotted the problem? It's a BEDMAS thing right here, isn't it? We haven't followed BEDMAS. So what they've done here is they've taken 2.5 times 3, which is 7.5, and then they took this 3.1 and made it 4. But we're not allowed to do that. BEDMAS says that I first of all have to do what's in brackets first. So I have to take the 3 plus 3. Let's get pen back. I'd have to take the 3 plus 3 and get 6. And then I'd have 6 times 2.5, which is 15. And then I'd have that 1 left over. Okay? So there is an error in calculation. You could say that. I would accept that this is an error in calculation because they didn't follow BEDMAS. But you know what? I would also accept that it's an error in reasoning because they didn't follow a math rule that we know, such as BEDMAS. To me, that's the same as dividing by 0. That's a no-no as well. So you could easily convince me it's either of these errors. Okay, so either an error in reasoning because they're not following known mathematical principles, or they're just not following BEDMAS properly, so they calculated wrong. Either would be acceptable as an answer. Okay, so as you're looking through the practice and you're doing the quiz, you need to pick between the 4 different types of common errors what type of error is in the proof. All right, that's section 1.5.